DT10 is a dynamic testing tool for embedded software engineering. It combines features from traditional tools like a profiler, tracer, debugger, and analyzer into a single tool, giving a comprehensive and centralized view of the runtime characteristics of your software. Here we see DT10 capturing the data from the software as it's running on the embedded device, and this can run for 32 days of continuous tracing. In the bottom left, we see the timing and state data captured from the software and relayed back to us on the computer. On the bottom right, we're monitoring the accumulating code coverage for each source file and function as the software is running. In the main window at the top is the output from the DT10 Multi-wave Scope. Here we're tracking software events and variable values synchronized with digital signals being captured from the device hardware. When we've finished our tests, we can use the DT10 analysis engine to process all of the captured data and build up a suite of reports and charts to give a comprehensive look at the runtime behavior of the embedded software. To take one example, the execution time report first displays a profile for each function, showing the number of times the function was called and the average max and min execution times for the function, shown here in nanoseconds. To debug an issue, you can easily pull up a listing for every call to the function. In this example, we see 3 instances where the execution time for the function exceeded a predefined limit. With DT10, you can input design time specs for the execution time of any routine or on a use case represented by any 2 points in the code. DT10 can then scan for any instance over 32 days of continuous execution where the performance has gone out of spec, and it will highlight this particular instance in the report. That's a great way to identify time-critical issues or an issue like a slow startup sequence that only happens once in a while. Then, once you've identified a particular instance, the DT10 test report displays the execution path for that particular instance, and you can step back through the execution offline to pinpoint where the problem lies. DT10 can also display the execution path in graphical format. The function trace report makes it easy to understand the execution trace profile. We can click each node in the path to replay the trace through the source code. The horizontal axis represents the depth of function call and the vertical axis is the timing. And we can quickly determine the execution time between any 2 points in the path. A function transition report shows the call relationship between the functions at runtime, both transitions between functions and the time spent on each function. And again, we can step through this runtime profile and monitor the test report and source code as we go. These reports provide different high-level perspectives on the runtime behavior of your software and then let you drill down to specific points of interest. Let's take a look at one more report. DT10's code coverage report highlights the statements and branches in the code executed while running on the embedded target. For each function, DT10 builds out a flowchart of the branch conditions. The yellow node represents a conditional statement that evaluated both true and false during execution time, whereas a red node is for a conditional statement that only ever evaluated to false, and so the code associated with that branch has not yet been tested. In addition to highlighting which parts of the code require more testing, this feature is often used to uncover errors in the execution paths and even as a teaching tool as part of a peer code review. You can contact Trinity Technologies today for more information on DT10.